This massive AI system has 8 GPUs, each with 96 gigabytes of memory, just as one of the options, and new, it costs only a fraction of the price of the highest end AI servers. But sometimes even that is too big, so that's why there's other 2U servers with GPU options. There's standard 2U servers that you can put GPUs into, workstations you can put GPUs into, smaller GPUs you can put into Blade servers, and even embedded edge servers are getting into the game with GPUs themselves. And if you just want a giant GPU in your workstation, you could put an NVIDIA RTX PRO 6000 into a Xeon workstation. And in the future, there's going to be an 8 GPU PCIe board that has up to 3.2 terabits of network bandwidth directly on the board. As you can tell, there are a ton of GPU form factors that are designed to go into almost any system, and that's exactly what we're going to go into today. Hey guys, this is Patrick from STH, and today we're going to talk about PCIe GPUs. Not the PCIe GPUs that you put into a gaming system, but the types of PCIe GPUs that you might put into a data center, edge device, and even a high-end workstation. Now at STH, we've done a ton with the highest end AI systems and clusters for years, but something that we've also been looking at for over a decade now is PCIe GPU systems. The fact of the matter is that most data center racks can't power the highest end AI systems, and so a lot of companies and folks are just looking at ways to install more AI compute and more GPU compute into their existing server racks. Now, a fun comment that we always get whenever we do the high-end GPU systems is like, can this run Crysis or Cyberpunk or whatever? And the interesting thing is that for a lot of those really high-end GPU systems, the answer is most likely no. There are a few limiting factors. Like, for example, you don't get the RTX cores if you're gonna go into the high-end data center GPUs. You just don't have access to those because those were taken out to add in more compute for like AI. But there are also features like you don't have a display output on the high-end GPUs these days. And so I called up Supermicro and I said, hey, I got this crazy idea. What if you guys could get me all of these different systems and we get a whole bunch of GPUs and we show folks a lot of different ways that you can deploy GPUs in systems that aren't those like super high-end, super expensive racks, really because let's face it, people have power budgets and just like monetary budgets. And plus, if you need your GPU infrastructure to do things like do VDI and design work on the same like machines that you're trying to do AI at some parts of the day too. I mean, it's just at some point, you need different GPUs. Now, of course, we had to go travel to Supermicro and we had to get all these systems together. So we have to say that this is being sponsored by Supermicro, but let's get to it. Now at STH, we've taken a look at a number of H100 and H200 SXM platforms just like this one over here. Now, of course, if you want the highest end AI training, that's probably the platform you're gonna use. But let's say you want more graphics features, or maybe you just don't have the power budget for something like this. Well, that is why you have PCIe GPUs, because you can deploy them almost anywhere. And so this system behind me is a really good example of a PCIe GPU platform and one of the 8 GPU platforms that we've been reviewing for generations. In fact, we've actually reviewed Supermicro 8 GPU systems just like this one all the way back in like 2015. So for about a decade now, we've been reviewing these. Now this system is the SYS522GA-NRT, which is a 5U 8 GPU platform. And so I figured, why don't we take a look at what's different with this versus some of the previous generations and see what makes this extra cool with the newest GPUs. Okay, so taking a look at the front of the system, you're gonna notice that this is a 5U platform. And on the front, we really have our storage and our cooling. But when you move behind that, you're gonna see that we have even more fans in the chassis. Behind these fans, we also have our 2 CPUs and our memory, and then behind that, that's where the big show happens, where we have our PCIe expansion with our various GPUs, and of course you can put NICs here too. So let's go through this front to back. Now on the front system, we have 24 NVMe bays. 8 of these go to the first CPU, 8 of them go to the second CPU, and then the final 8 tied to the 8 GPUs that you'd have in the back of the system. They go through the PCIe switch infrastructure, and that lets you do things like GPU direct storage. Now, of course, 24 NVMe drives, that generates a decent amount of heat. So what we have to manage the heat in the overall platform is we have this bar right here. This extra U allows for more airflow through the chassis. Then above that, we have our row of hot swappable fans. So you can see we just pop these things out, and there you go. But these are not the only fans in the chassis, because what you'll see if you come over here just behind is that on the bottom, we actually have another set of hot swap fans that you can just open the chassis, pop these things out, they slide in and out super easily. And this gives you really 2 zones, right? You get that top zone, which is pushing air through to our GPUs directly. And then we have another set which gives us a little bit of redundant airflow, plus it gives us our airflow to our CPUs. Now, of course, there is a CPU and an airflow guide that's right below here, so we'll hit the two little latches, and then we can plop this out, and you're gonna see our CPUs and memory slots below this. Now, this has dual Intel Xeon 6900P processors, codenamed Granite Rapids AP. That gives us 12 memory channels per CPU and 24 DIMMs total. These are the processors that can go up to 128 full performance cores per. You can also use MRDIMMs, which go up to 8,800 megatransfers per second, so much higher speed than your standard DDR5 if you just want that extra memory bandwidth. And between the two sockets, we have up to 256 cores, 512 threads, but we also get up to 6 terabytes of memory capacity. That is a lot more than in previous generations. Now, behind the CPUs, we see our MCIO cabled connections, and these MCIO connections go from the motherboard up to the PCIe switchboard. There's 2 PCIe switches here, and we get a total of 13 slots. Now, you can see here that we have 8 GPUs, and these are the NVIDIA H200 NVL boards. So we get NVLink, and these are the NVLink bridges. We get 4 of these, and each one has 141 gigabytes of memory. So because of this NVLink bridge, we get 564 gigabytes of memory on each side of this platform. Now, of course, the NVIDIA H200 NVL is an awesome option in PCIe, but there are folks that want to do things like have graphics capabilities. If you maybe have a node that you want to do rendering on, or maybe you want to use as a remote workstation, then instead of the H200, the option is really to go and get the NVIDIA RTX PRO 6000. These have a lot more of those RTX style features where you're able to go do a lot of those more graphically intensive workloads. But at the same time, you get 96 gigabytes of memory per card, which still allows you to have a lot of memory, while at the same time also lowering your cost and giving you some graphics capabilities. So one of the really cool things about that RTX PRO 6000 setup, especially when you have 8 of them in a platform like this, is that you could use them during the day, for example, for VDI, you could use them for remote desktops, remote workstations, heck, even rendering, but then at night you can go flip them and use them for AI workloads. Now, platforms like this, in previous generations that we've reviewed, were often called 10 GPU platforms. And the reason for that, you can see we have 8 here, 4 and 4, but you can put another 2 GPUs in the center, and technically you could put 10 GPUs here. You can also, even with those 10 GPUs, you could even add a NIC on the side and get a little bit of extra networking. Now, that's how folks used to deploy these, and I'm sure that there are folks that are going to deploy them in this generation in a similar manner. However, in this generation, what is probably more common is that you'll see something like this where you have a 4 GPU NVLink setup, plus you'll have 2 NICs, like an NVIDIA Connect X7, for example, that would be used for your east-west traffic. So you might have 2 NICs here, and then what you would have is you would have another NIC here, and that would be for this set of GPUs, as well as one on this side. And that gives you, 2 NICs and 4 GPUs, or 1 NIC per 2 GPUs. But because you have 13 slots, then you can still use the center slot for something like a north-south network, using it for NVIDIA BlueField 3 as an example. So even though I said that this is an 8 GPU setup, really what this is designed for is to be 8 GPUs plus 5 high-speed NICs, all on this PCIe board. Now, to power this server, there are 2.7 kilowatt power supplies. These are titanium level efficiency power supplies. And the reason you need so much power in this is because, well, you have 2 CPUs, 24 DIMMs, you have another 24 NVMe SSDs, plus say 8 or 10 GPUs, a bunch of NICs, and frankly, more power than we used to use in previous generations, especially back in those like 2015 era systems that we would test. And something that we covered on the STH main site is that NVIDIA has a brand new ConnectX-8 PCIe GPU board for their new MGX systems. We covered this during our Computex coverage, so you can go check that out, but we can actually show you what the assembly would look like. You'll see that on one side we have all of the PCIe slots, and that looks kind of standard, but what we're missing on this side is really the PCIe switches that we see in traditional systems. Frankly, we've seen the 8 GPU systems with PCIe switches for over a decade at this point. But what NVIDIA is doing on this board is they're using the NVIDIA ConnectX 8 NICs, the highest speed NICs that you can get. And on the bottom side, you're gonna see that we have 8 different ConnectX 8 NICs. Now these ConnectX 8 NICs have 2 main features. The first feature is that they feature, of course, the 800 gigabit per second networking that can do either InfiniBand or Ethernet. And then on the other hand, it has an additional PCIe switch. So there's actually a 48-port PCIe Gen 6 switch, which means that 16 lanes, of course, go to the network controller, but then there are 32 lanes, 16 for each GPU. The reason that's important, and NVIDIA is not really saying this and talking about this too much, but having a PCIe Gen 6 switch on board means that if you have PCIe Gen 6 GPUs, you can have those do communication from GPU to GPU, and you can also have that 800 gigabit link off of that network, right? Which is just crazy fast because a PCIe Gen 5 by 16 bus just can't even support that. That's stuck at about 400 gigabits per second. And of course, the other implication of this is that if the ConnectX 8 is at 800 gigabits per second or PCIe Gen 6 speeds, and you have GPUs that eventually become PCIe Gen 6 GPUs, you don't need a PCIe Gen 6 CPU to be able to have that GPU to GPU communication or the GPU to network communication at that higher PCIe Gen 6 speed. Now, of course, this got announced after we recorded all the rest of this video, but I wanted to go and address it here because I think it's important just for the future of these systems that we saw the Supermicro version at Computex.
But one of the coolest things about PCIe GPUs, and the reason that they get used everywhere, is because they don't need dedicated boxes like this, or like with the SXM platforms, where the entire box is really dedicated to those high-end GPUs. Instead, you can actually put GPUs in a lot of just standard 2U chassis. So let's get to some of those next. This is a Supermicro Sys212GB&R. And what it is an NVIDIA MGX-Style platform where you can see that we have a single Intel Xeon processor using R1S. So this is an Intel Xeon 6700P processor. R1S, we get 136 PCIe lanes, even though we still only have that one processor. That matters because in the back, we have 4 GPUs. Now we can have the NVIDIA H100, NVIDIA H200 NVL platforms, and we can also have the new NVIDIA RTX PRO 6000 series. So there's a lot of different options when it comes to the GPUs in the rear of this. But because we have this single socket platform that's an R1S platform, we can still have our E1S NVMe bays even with that single socket. And while we're on the front of this, let's also just take a look at the power supplies. These power supplies, you can either plug in power directly here, or you can power these via the rear of the rack due to this power routing through the chassis. And so this system has a single Xeon CPU for lower power and lower cost, but you still get 8 DIMMs per channel and up to 16 DIMMs in this platform, which is a decent amount. Plus, you also have room to have multiple NICs in the back as well. Now, so far, we've really looked at GPU servers, things that have 8 GPUs or 4 GPUs that are really designed just to be GPU servers, but a lot of folks deploy servers just normally, whether those are virtualization hosts or just general purpose compute nodes. And now, these days, you might want to go put PCIe GPUs in there really to add that acceleration, either for AI or graphics. And if you want to do that, you would use a server like this. This is our Supermicro Hyper system that we've reviewed for generations now. Now, you'll see that this is the newer Hyper design where we have the 8 NVMe bays in the center and then lots of room for airflow because we have a ton of compute in this platform. We have 2 Intel Xeon processors, plus we have all of the memory that we could use, and then these special airflow guides, which go back to our NVIDIA GPUs in the back. Now, of course, we could have things like the NVIDIA H100, H200 for those AI compute scenarios, or if we want to add an RTX PRO 6000, we can add several of those in the rear of the server, or we can just do what we're doing here, which is we have 2 GPUs that are double width GPUs. Plus, we have the ability to go and add extra NICs onto this if we want high-speed networking as well. We could also have HBAs if we want to have SAS or whatever. We could have different RAID controllers, all kinds of different configurations, because this is just a standard server, except it can now power and cool these high-end GPUs. And one of the coolest things about the NVIDIA RTX PRO 6000 is that there are versions not just for the big servers, but also for workstations. So you can see right here that we have an NVIDIA RTX PRO 6000 installed in this workstation where we can have both a Xeon W, plus we can have a giant 96 gigabyte GPU for things like local AI development. Now, so far, we've shown a lot of the high-power GPUs, the NVIDIA H200 NVL, H200 NVL, and the RTX PRO 6000. Now, these GPUs typically use somewhere in that 400 to 600 watt range and are relatively high-powered GPUs. But not every situation calls for those high-powered GPUs, and sometimes you just can't even put them in there. But if you do have a system where you can cool a 75 watt PCIe card and maybe even a low profile card, then there are GPUs like this. This is the NVIDIA L4, which you can put into almost anything. And you can even put these GPUs into places that you wouldn't normally think. Like, for example, you can pretty easily put these into the Supermicro Blade servers. And so if you have a Blade chassis with a bunch of new blades that you want to go and install GPUs into, so you do AI inference, that's a really good use case for something like the NVIDIA L4. Now, of course, Supermicro has dedicated GPU blades, really for those higher powered GPUs, but this is a great option if you just want to add some AI inference capabilities to a standard compute blade. But of course, high-end GPU servers, standard servers, and even blade servers aren't the only computing form factors. So what about the edge? Okay, now for one of my favorite systems, and one that if I could have a server crush on a server, it would probably be this one, because this is a Supermicro E403 14B. Now, this is an edge server that you can mount to all kinds of surfaces. You can put it on a wall, they have brackets and all kinds of ways that you can go and mount this thing. And the real idea is just to be a versatile edge system, but it's also super cool. Now, on the other side, we have just fans, but this little chassis has so much going for it. And let me just kind of show you some examples. Like, you can open this up and you get to the fans that are over here. And this is what keeps the entire chassis cool. But then once you've done that, you can pull off the top. And what you can see here is that we have more GPUs because we have this riser that you can remove, and you'll see that we have our two NVIDIA L4s that are right here. You can also put another NIC in here if you wanted because you have plenty of PCIe expandability. And these NVIDIA L4s are perfect for this because they don't use that much power, which is important in edge scenarios. Also, the NVIDIA L4 has NV encode decode, so if you're doing things like video analytics at the edge, these are awesome little cards. Now, beyond the GPUs, you also, of course, have your NVMe drives. Inside this, you'll see that we have our Intel Xeon processor, we have our 8 channels of memory, plus we have our PCH, room for M.2 SSDs, our baseboard management controller, all of the types of things that you would want in an edge server, and even options for redundant power that we have over here. And mark my words, one of these days, I'm gonna get to review my server crush. Hopefully Supermicro will let me do that soon.
Now, in all of our videos, I like to have key lessons learned. I mean, what do we learn by doing this entire exercise? And I think there are a number of things that are pretty darn exciting, right? The first thing, if you've been following STH since like 2015, you'll know that I am a big fan of these PCIe GPU systems. I just think that they're super cool. And the fact is that they are very flexible because you can have things like GPUs that have NVLink with the, for example, the NVIDIA H100 or H200 NVL GPUs with the NVLink bridges. You can also really focus more on those graphical or mixed AI and graphics workloads with cards like the NVIDIA RTX PRO 6000 series, right? Get 96 gigabytes, but also a lot of these GPUs are at a much lower cost than when you get up to like the larger SXM systems. And of course, the new NVIDIA ConnectX 8 PCIe switchboard for these MGX-8 GPU servers. This is one of the most awesome things because it does totally change the architecture. Instead of having a big switch, you instead have the NVIDIA ConnectX 8 NICs providing that PCIe Gen 6 feature, plus also having the ability to go and run networking that's just ultra fast at 800 gigabits per second. Aside from the power savings by moving to lower TDP GPUs and the feature benefits of being able to run both AI and graphics workloads with a lot of these GPU options, I think another big one is just the fact that these GPUs tend to be a lot less expensive. At the time that we're recording this, a high-end GPU can easily cost $30,000 or $40,000. On the other hand, these NVIDIA RTX PRO 6000 cards tend to be well under 10. And of course, when you multiply that by 8 GPUs in a system, well, that saves a ton of money. money. But while those 8 GPU systems can be awesome as options to be a little bit lower cost, but still get you a lot of the AI performance that you might want, another thing that I think a lot of folks are going to start doing is adding GPUs into just general purpose servers or edge devices, workstations. Well, I think a lot of people already do workstations, but higher end GPUs that can do more and more AI work. And I think a lot of folks are already seeing AI impacting workloads. So as you're seeing this happen, you might have to start adding AI as part of just general purpose workflows, right? You may have like an ERP system or some other kind of application where you're adding a little bit of AI inference into. And so one idea and one model in doing that is really to have your general purpose servers or kind of more standard servers, but then adding GPUs in there. So that way you can run your normal workflow, but then when you need that AI inference, instead of having to go over the network and go to a different server, you can just go to a local GPU. A lot more companies are buying GPUs and putting them into servers because they are starting to do that AI inference locally in their applications. And some other folks are just saying like, hey, for an edge device, for example, if I'm gonna go install this thing, it's gonna be out there for 5 years. I may not know exactly what I need today, but I'm probably gonna be doing more video analytics or whatever in the future. And if that's the case, well, I kind of need to go and have some kind of inference device or inference accelerator in those, because I may not know exactly what the workload is gonna be, but I know I'm gonna have to do inference and I'm not gonna go out and touch this device again. So I might as well just go and put them in there now. Now, whenever we do these videos, there's always folks that deny it in the comments, but then on the other hand, they're also seeing, build outs of AI clusters that are in the tens of billions of dollars, people deploying these things all the time. And that's a big trend in the industry. I mean, this is happening, guys. And so if you want to learn a little bit more about this, we're going to have on the STH main site a little bit more information just in terms of what the different types of GPUs are and kind of mapping those really to those applications and where you might use them, just to make it a little bit easier for if you're ordering servers and you might want to go put a GPU in there just to maybe future-proof a little bit your server. Well, that is something that we're going to have, so you can just bookmark it as a reference. But hey guys, I'd love to hear what kind of applications you're building and what you might use these for. So if you have any ideas, definitely put those in the comments. Also, if you like this video, well, why don't you share it with your friends and colleagues, but also give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.